Okay, can you see the screen? Can you see the screen?
Yes, sir.
Okay. So now we start with the core topics of our syllabus, and what is the most simple thing? Electrostatics, and start with Coulomb law. This everybody knows. Okay, what does Coulomb's law say? If there is a charge Q1 and there is a charge Q2, and this vector is say R12, then force on the charge Q2 due to Q1 due to F2, that is given by 1 by 4 pi epsilon naught Q1 Q2 by R12 square. What is wrong in this equation? Anyone? What is wrong in this equation? Something is wrong.
Sir, R is a vector.
R is a vector. Okay. Is it correct now? Is it correct now?
Yes, sir.
Yes. Sure, everybody is correct. Still wrong. What is wrong? What is wrong in the equation? What is wrong in the equation? Anyone? Something is terribly wrong. What is LHS? What is LHS in the equation?
Vector F2.
Vector F2. And what is right hand side? What is F2 by the way? F2 is? What is F2? This you have learned in school for sure. What is F2?
Force
Force.
applied
So
on
force is a
Q2.
scalar or a vector? Force is a scalar or a vector?
Vector.
Vector. Right hand side, is it a scalar or a vector? Left hand side is a vector.
Scalar.
So a vector cannot be equal to a scalar. That's what wrong in the equation. How to correct the equation?
Yes, sir.
Vector cannot be equal to a scalar. So this equation is wrong. But how to correct it?
Multiplying a directional vector R12
This way?
by multiplying these with directional vector
This
R12.
way? This is what you want to say?
Unit.
Unit vector.
Unit vector. Very good. So how to get this unit vector? You want to multiply it by this one. You want to multiply it by this one. So now it is perfectly okay. Or we can write the same thing.
Using cube.
Yes, absolutely right. This is also simple. Okay. So now it is correct. So if F1 is the force due to on Q1 due to Q2, then we know very well that F1 would be simply the negative of F2. Right? This is well known. This is well known. What is this? What is this?
Permittivity of free space.
Absolutely right. Very good. What is the value?
8.854 into 10 to the power minus 12
units.
something.
Yes, our value is correct. Absolutely correct. 8 epsilon naught is 8.85 into the power minus 12. But units. Anybody? What is the unit
Joule
of epsilon?
second. Joule second.
Joule second. Any other? Are you sure? Because there are coulombs. So Joule second will not usually have.
Coulomb square per Newton meter.
Yes, if you reverse it, but there is a much simpler expression. Actually, let me tell you that one of the previous batches, I gave this question in the exam that what is the unit of epsilon naught. So many people did the reverse thing and gave this the same answer. And Newton meter square by coulomb square. This is technically correct. But there is a better way. It is Farad square. Okay. How to find it is, you know the expression epsilon 11 A by B, that is C for parallel capacity. Check. C is farads, A is meter square, B is meter. Farad square. Okay. So this is fine. This is true when they are in vacuum. If they are in some medium, some dielectric medium, then we add something called a dielectric constant or relative permittivity. That is Q1, Q2, R1, but R1. This we know from the school. There are some problems which I am sure uh, no need to revise. We have done in the school. Like there are two charges given in 2 points. What is the force between them? You can practice this problem. They are given in the books. I think you would be able to do this. You still are stuck, you can definitely ask me. So, but no point in doing that. Next is electric field. First question was the unit of electric field. The very first question we ask ourselves. What is the unit of electric field? What is the unit of electric field? Anyone?
Sir, can you repeat the question?
What is the unit of electric field?
Volts per meter.
Volts per meter. Absolutely right. Some say electric field intensity also. Some is true, but it's shortened very more colloquially. So if I have a charge Q, what is the electric field at a distance r from it? Assume that it is in vacuum. Okay, so there is no epsilon r.
AQ square by R.
E would be 1 by 4 pi epsilon naught Q r by r. Well known. And if there is another charge Qt, then the force on Qt due to Q, that is F equal to Qt times E, that is 1 by 4 pi epsilon Q Qt r by r. So another way of expressing our electric field is E equal to F by Qt, or force per unit charge. Some people, that's why they say it is newtons per coulomb. but it is not very appropriate to give the names of two scientists in the same unit. So volts per meter is probably more correct. Mathematically, newtons per coulomb is also right. Okay, clear? Anything you want to ask? Anything you want to ask? Anyone? Is it okay, or you want to ask something? So tell me.
It is okay, sir.
Okay. Yes, Arpit, right. But we don't give Kulo as Q. We say this Newton's first. Kulo is given by C. Okay. So this is better. Acha. Fine. So now tell me. I have got many charges. Say Q1, Q2, Q3. The position of this Q1 is R1. Position of Q2 is R2. Position of Q3 is R3, and up to Qn, Rn. So what is the combined electric field by all the charges? What is the combined electric field by all the charges? Anyone?
0.
Hey. Zero is possible, but not probable. Any other answer? Any other answer? F E is simply the summation I to N EI, where EI is 1 by 4 pi epsilon naught Q Ri by Ri. So the total field is the superposition of all the fields. Correct? If there are many charges, then the total electric field in the region is the superposition of all the electric fields created by the charges. Is it okay? Is it okay? We can simply add them linearly. Any doubts, any questions? Is it okay? Is it okay, or we should? Any you have questions? Tell me.
Yes, sir,
It
it's
is
okay.
okay,
It is
sir.
okay. Good. So the next thing, which is a bit, this will be a bit lengthier. That is, do you know this? Do you know this? Electric potential. Have you studied this before?
Yes, sir.
What is electric potential then? Anybody? What is electric potential? It could be wrong or right, it doesn't matter. But attempt matters. What is electric potential?
The amount of work needed to move a charge from one place to another.
From
One place to another.
okay.
Inside an electric.
Yes, the electric field is there. Fine. Let us consider there is an electric field exists in the. I have got a charge Q, okay, located at the point RE, and I want it to move to this point RB. The charge volume is Q. Okay. So I have to do some work. Okay, work done against the field. So W is defined as we had seen F ds. The negative because we are doing the work against them. Right? Now what is F? What is F? F is equal to Q. So W equal to Q EDS. Q does not change. You can take it safely out of. This is point, of course, RA. RA. But this time, assume Q equal to 1 to 2. So W equal to EDS. Right? Now let us look at this integration. Let's look at this integration. I had said to move from point RA to RB, but I have not said how. I can move in a straight line. I can move this way, then come here, this way, then come here, or anything, or any like this. Many there are infinitely possible, large, infinite possible of amounts of it. Okay, is it correct? To move from point A to point B, there could be infinitely large number of ways. Agreed? Is it okay?
Yes. Yes.
But I have not specified which way. I have never said to go on a straight line. It's up to you. The thing here is that will this value of W depend on whatever path I take?
No, sir.
It will not.
No, sir.
It will not. Of course, it will not. But how? Let us go the straight way, straight path. So W would be simply, let us assume that F is in the same direction as this. Okay. F is in the, but E is in the same direction for our convenience. E is in the same direction as this RAB. E and RAB is in the same direction. So their dot product is 1. So W would be E ds, because dot product is 1. But what is E? E was 1 by 4 pi epsilon naught. Assume that it will be 2 by r square, sorry, minus r square here, RB to RA. So minus of this. Is it correct? Is it okay?
Yes, sir.
So Q by 4 pi epsilon naught R inverse RB to RA, or Q by 4 pi epsilon naught 1 by RB minus 1 by 1. This is the work done.
Yes, sir.
Okay, this is coming. Straight line. Second, E is still along RAB, but I am now not moving like this. I am moving here to this RA prime. Now I am moving in a direction which is in phi, which is perpendicular to this R to this point. Okay. What is the field now? We will find the field once again exact same. Because here to here there is no work.
Can you repeat one?
Sure. E this is the one straight way which we took last time. If we take another way, Possible?
Yes.
As what is the work done here?
Work done will be same.
Same, right? It can be shown. We'll take the calculation, you can take theta and so this W depends on these positions of this point. So we can write it as phi B, phi RB minus phi RB. Is it okay? Is it okay? This W, it depends on RB and RA only. And of course, Q is there. Fine, but Q is there. This W depends on RB and RA only. Correct?
Yes.
So
Yes,
can we
sir.
write it as functions of this and this?
Yes.
So this electric potential, as somebody said, from infinity to the point, or it measures with respect to some reference point to the point. So the potential phi at a point R is given by phi R minus phi R0, where R0 is the reference point. Potential at a point R, it is given by this value, work done to bring the from the reference point to the given point. Okay. If RA is my reference point, then what is phi B, phi RB? If RA is my reference point, then phi RB would be W plus phi RA. Is it okay? Assume that RA is my reference point. Then what is our phi RB? Phi RB is phi RA plus W. Is it correct? Is it okay?
Yes, sir.
If phi B is my reference point, then so if RA is my reference point, then phi RB is W plus phi RA. Usually we take the reference point as R0 or something infinite, whatever. So phi RA is delta WA plus phi R0. Phi RB is delta WB plus phi R0. So what is phi RB minus phi RA? Is simply delta WB by delta WB. So work done is simply this change. This is the potential. So work done is simply the potential differences of the two parts.
Sir,
Ask
can I ask a hypothetical question?
you can.
Sir, this work done we are measuring with a reference point in
Hmm,
context
hmm,
reference
hmm.
point.
Yes, usually it is infinite. Okay. If it is
But
infinite, then you can yes.
if we don't have any reference point and there are two charges,
If
how
that
can we measure?
if there is no reference point, it is taken.
Yes.
Look, if there is no reference, usually this reference point R0 is infinite. Okay. So then W would be just be found out 1 by 4 pi epsilon naught 1 by RB minus 1 by R0. If this is infinite, then obviously this will become 0. So W equal to 2 by 1 by 4 pi epsilon R. So if there are two charges, then W would be Q1 1 by 4 pi epsilon naught R1 plus Q2, like that. This is simpler. You can add in the scalars. That's what you are saying. Is that your question? Is that your question? If there are two charges, think this way. If there are two charges, then W would be same integral E ds. But now what we see, E equal to E1 plus E2. There will be two different electric fields. So this will be E1 ds, E2 ds. Once again, that will be phi 1 A, phi 1 RB minus phi 1 RA plus phi 2 RB minus phi 2 RA. This will be thing. If this is delta phi 1, this is delta phi 2, then this is delta phi 1 plus delta phi 2. Is that your question? Is that your question? Sorry? Have I answered your question or not? Is this you want to know, or you have something else? If there are multiple charges, you can simply apply principle of formation like what I have done and find the potential. No problem. Usually we measure potential with respect to infinite. So the potential due to 1 point charge, it comes to be 4 pi epsilon naught r. Is it okay or is it a question? Ayush, did I answer your question or not? Did I manage to answer the question or not? Okay, fine. So let us discuss something else. Acha, electric potential is a scalar or vector? Potential is a scalar or a vector? Scalar, absolutely. So phi is a scalar. Now, let us say that in a plane or in a area, a volume, there exists an electric field E. E is X I Y J. Okay, and I have a charge of 1 coulomb, which I am moving from X Y Z to X plus del X Y Z. So from the discussion we had just now, W would be phi x plus del X Y Z minus phi X Y Z. Is it correct? Is it okay? Is it okay from just now what we
Yes,
discussed?
sir.
Yes.
Yes. But W is also equal to E ds, force in displacement. That is equal to, what is ds? What is ds here? Negative, of course. Of course, it is negative. Q is equal to 1 coulomb. What is ds? What is ds? What?
The root over x plus del x minus x square.
Root
I
over
mean,
this distance. What is this distance? From here to here. This point A to
del
point
x.
B.
Del
Yes,
x.
del x, absolutely. And is a vector. So what vector to put? Del x is a scalar, but ds is a vector. So what to put to make it a vector? What to put to make it a vector? Anyone?
I cap.
I cap, because I am moving in the plus x direction. So E dot ds, this would be minus Ex dx. Is it okay?
Yes, sir.
Okay.
Yes, sir.
Only Ex will survive because the Ey and Ez they will be 0 because our J dot I is 0, K dot I is 0. So what we found out that phi x plus delta x yz minus phi x yz that is equal to minus Ex del x, or my Ex equal to minus of phi x plus del x yz minus phi x y z, right? We can write this. We can write this. If
Yes, sir.
delta x tends to 0, then what is the x? Then what is the x? Anyone?
minus gradient
Gradient comes later.
gradient of v.
Gradient comes later, my friend. That's what I am trying to come to this result. But
Minus of d phi by dx.
yes, minus of d phi by dx. Similarly, we can write dy equal to minus d phi by dy del y, and ez equal to minus del phi by del z. Agreed? Similar logic we can use.
Yes, sir.
Okay. So now we can come to what Arpit had said. Negative gradient of phi. Is it okay?
Yes.
Right? So now why is phi important? Why is phi so important? Because phi is a scalar. So we only want to know one value. Only one value of the scalar. But E is a vector. So we need to know three values. X component, Y component, Z component. But if we know only one value of this phi, we can calculate all three components of it by simply using divergence. Isn't this great? Is it okay?
Yes, sir.
Right. Now, what is curl of E? Divergence of E we will discuss in the next class in great detail. Okay. So I will not say anything about divergence of E in this next class. Divergence of E we will discuss in great details in the next class. What is curl of E? There is a vector of this. What will be curl of E? Anyone? What is curl of E? Curl of E is simply curl of minus grad phi, because just now we have seen E is minus grad phi. We can write this. We can write this.
Yes, sir.
Okay. And what is curl of a gradient? Very first class we discussed. What is curl of a gradient? First class notes. Okay, okay. Fine, no problem. What is curl of a gradient?
0.
0. So curl of E is 0 for a electrostatic case. This is not valid every time. Just don't put blindly curl of E is 0. For electrostatic case, curl of E is 0. Okay. If curl of E is 0, using Stokes theorem, we can write this is also 0. Is it okay? If curl of E is 0, then by Stokes theorem,
Yes, sir.
we can write this. What does this mean? What does this signify? What does this signify? Remember, we just now were discussing these things. Only thing is that there is not that small circle is not there. It is here. What does this signify? Just now we are discussing this type of things. Very similar. See, very similar.
Sir, work done by the electric field on a charge is zero.
When?
In a closed surface.
Just surface.
Closed.
At a point.
In a closed
No
path.
point.
In a closed path.
Closed path. So work
Path.
done by the electric field is zero when it is moved from a closed path from one point back to another point. Obviously, because that will time W will be what? Phi RA minus phi RA. That is, has to be zero. What did we see? Work done from moving from RA to RB was phi RB minus phi RA. If I move from RA to back to RA, it will be phi RA minus phi RA, that is zero. Another will be true. Correct? Correct? Okay.
Yes, sir.
So, electric field is an example of what? Rather, electric field due to
Conservative
static
field.
charges is example of
Conservative.
conservative field. Yes, electric field due to static charges is always conservative. With this note, I end today's class. If you have any questions, you can ask. So 5 minutes are there. If you have any questions, you can ask. The attendance is already done. Next class, we will do divergence of E, then this Gauss theorem, any other. On Saturday, next class will be on Saturday. On Thursday, there will be at 5 p.m. there will be gap for. Any questions?
Which book to refer for this? I mean this part.
5 months lecture. Very good. Everything I will be teaching you is from this. Except the coordinate system, those things are not there. But other things that it will. Okay, anything else? If you give a Google search, then you will find a link where you can download the book, or not download, read the book legally. Okay, I have already shared the link with you. You just go to the link, you will see the book there. Everything, like whatever there is in the book, you find the same things on the website. You can read the book from. It's a very good book. So I suggest you read it. I have covered chapters. One was from the basic vector calculus. I think no, so two. Chapter 2 was from this grad divergence and curl. Chapter 3 was vector integration. And this chapter we are now doing chapter 4, which is electrostatics. Later we will gradually move to other books, okay, which are more specific to our subject. This is a general physics. It's a very good book. That's why I do. Anything else? Anything else? Any other question? Practice problems.
No, sir.
As I already tell you, 50% of the questions will be from problems, just problems, and 50% will be theory. Whatever mode, it will be online mode or offline mode, whatever mode you exam will take, I do not know. But no matter whatever mode is taken on, 50% will be theory and 50% will be problem. So it's very important that you practice problems, because if you start practicing problems the day before the exam, you will not be able to study. This subject is not designed for cramming up the last day before the exam. It's not designed for that. So 5 minutes are there. Okay, then we close. We meet on Thursday for Group B students and Friday on for Group B students. Okay, thank you very much.